Hello, this is Kim Nelson, and this is going to be another video on solids modeling in Rhino. In this video, we're going to use solid modeling tools to model channel settings. The first thing you'll need are the assets that I have posted for you to use in creating these models. So go ahead to wherever you store these on your computer, and you will see that these assets include a 2.5 by 1.5 millimeter baguette and a 2.5 by 2.5 millimeter square or calibre cut. I'm going to maximize the perspective viewport and then begin to create a layout of 6 of these calibre stones in a row. I'm going to begin doing this by using the copy command found on the transform. Select objects to copy, and then click on the top C-plane to select a point to copy from. And to copy to, we're going to need to enter a distance, which will be 2.62, because we want to maintain a spacing of 0.12 millimeters between each stone. So holding down the Shift key to constrain the marker to ortho, pull to the left, and I'm going to continue with the layout by repeating the copy command, selecting the stone I just copied as the object copy, and then for my point to copy from, I'm going to pick at the far right front corner of the original stone using my end object snap. And for my point to copy to, I am going to pick on the far right front corner of the stone that was just copied to then create a third stone in a row. Repeating the command again, I am going to select the 2 stones on the left as my objects to copy. My point to copy from will once again be the far right corner of the original stone using the end snap, and my point to copy to will be to pick the same corner on the third stone over and hitting enter. And I'm going to repeat the command one more time by hitting spacebar, picking the 5th stone I created as my object to copy, and for my point to copy from, picking the far right front corner of the 4th stone I copied, and my point to copy to the same corner on the 5th stone over, and hitting enter to complete the row of 6 stones. Models should always be built around world center. In order to center up my layout of stones here, I'm going to be using a circle that I create using the circle diameter. I'm going to want to draw this circle vertically using the front C-plane. So activating front C-plane by going to the Curve Tools tab, I'm going to choose the Circle Diameter command from the side toolbar. I need to draw the circle diameter so that it is centered up between the 3rd and 4th. To position the circle accurately, I'm going to need to use the mid object snap along with the project to C-plane option on the object snaps toolbar. I'm going to start my diameter at the middle of the girdle of the 4th stone, and as I click you can see how the pick point elastic bands or project straight onto the front C-plane. I'm going to put my end of diameter point at the middle of the girdle of the 3rd stone, which will then complete the drawing of the circle, providing precise reference geometry for centering up this group. So moving these into position, I'm going to begin a move command by typing enter. Then for my point to move from, I'm going to pick at the center of the circle I've created by activating the center object snap. For my point to move to, I'm going to type in 0 and this calibre stone came from my stone library, and like all stones from my stone library, it is a grouped object consisting of a solid polysurface and a closed curve for the girdle. To ungroup this set of stones, I'm going to drag a window selection around the entire set, and I'm going to type in Control-Shift-G to ungroup. Then I need to just grab the girdles for these stones, so I'm going to drag another window selection, a narrow selection around the girdle lines to select just the girdles, and then I'm going to go in and hold down the Control key and deselect the girdle line from the stone furthest to the left, and then hit delete. Now it's time to start drawing our channel setting, beginning with the opening in the top of the setting for our stones. I will do this by using non-uniform scale to stretch this girdle from our far left stone until it reaches the full length of our entire set. I'll begin by returning to my default working C-plane, which is the top C-plane, by hitting. And now I'll select non-uniform scale by going to the transform tab and picking non-uniform scale from the scale button pop-out. The object I want to scale is the girdle curve, so I will select it. And the origin point for a scale command should be a point on or in reference to your geometry that you do not wish to change or move. For this selection, that point would be the midpoint of the outside girdle. So I'll make sure that my mid object snap is active and then go ahead and click at that midpoint. Now, non-uniform scale provides the ability to scale in each of the three axis directions independently. For this selected girdle curve, we'll be scaling in the x-axis. For the first reference point, we will pick on the inside midpoint of the girdle. And for the second x-axis reference point, we will be picking on the midpoint of the outer girdle of the stone that is furthest to the right. The next direction this command will allow us to scale along is along the y-axis, which we do not wish to change. If the number between the brackets in the command line is 1, we can just hit enter and accept that as 100%. If it is not number 1, then you would need to change it to number 1. The same thing is true for the y-axis. Simply hit enter to accept 100%. Now that I have this curve, I'm going to change it to my drawing layer by entering Control D and then moving it to the Curves 1 layer. And now I need to offset this curve to establish the outer boundary for our channel setting. The wall thickness for a channel setting is a technical as well as aesthetic consideration. You don't generally want them in excess of 1 millimeter in thickness, nor do you want them to be less than 0.6 of a millimeter in thickness. The thickness that you decide upon should be based on the size of the stones that are going to be set. For stones this size, 2.5 millimeter calibre, wall thickness of 0.75 millimeters, 7.5 would be appropriate. I'm going to choose the Offset Curve command from the Curve Tools tab. For the curve to offset, I'm going to select the outline for the opening. I'm going to type in a distance of 0.75, hit enter to confirm the distance, pull to the outside to pick my side, and click to end the command. To create the main block or body of the channel setting, I'm going to be extruding this outline curve. Going to the Surface Tools tab and then selecting the Extrude Straight command, I'm going to pick the curve to extrude as the outline of our channel setting. I'm going to hit enter when done, and then I'm going to extrude the curve. I want it to extrude both sides yes and solid yes, since I want a solid object, because of course we're doing a solids modeling project here. Pull the depth until it captures the full depth of the pavilion of the stones, and then click to enter the command. I'm going to need to move this block down vertical in the world z-axis. In order to do that, I'm going to need to activate a vertical C-plane. So I'm going to hit F-enter to activate my front C-plane. Type in M-enter to begin the move. And then for my point to move from, I'm going to pick on the front C-plane. Holding down the Shift key to constrain ortho, I will then move the block down until the tops of the stones, the tables, barely break through the top of the channel setting block. Once I have reached that point, I will click to accept the movement and end the command. So that's the first block of our channel setting. Next, we need to create the two interior support bars. I'm going to place these bars on either side of the two center stones, here and here. To help find the location for these support bars, I'll use the same reference circle that I drew when centering up the stones. I'm going to copy this circle into location using the copy command off of the Transform tab. For the objects to copy, I'm going to select the circle and hit Enter when done. I'm going to need precise movement using object snaps, so I will activate End Snap and deactivate the Project option. My point to copy from will be the front right corner of the stone to the right of center, and my point to copy to will be the front right corner of the stone left of center. Press Enter when done. I want to draw a vertical construction line right through the center of this new circle. So I will go to the Curves tab and then select the Single Line command from the side toolbar. The start of my line will be the center of the new circle, so activating Center Snap, I will touch the edge of the circle and select the Both Sides option from the command line. Then I will hold down the Shift key and pull this curve straight vertical up and down until it extends beyond the circle. I want to create 2 additional construction lines to establish the width of the bar. A good width for this support bar would be 7/10 of a millimeter. I'm going to pick the Offset Curves command from the Curves tool tab. I'm going to select the vertical center line as the curved offset. I'm going to make sure that the Both Sides option is active, and then I'm going to enter 0.35 millimeters in the command line, and then click to select my side to offset. I will then use the circle to trim off my construction lines to equal lengths by choosing the Trim command off the side toolbar, choosing the circle as my cutting tool, and then choosing the 3 construction lines as my objects to trim. Using these construction lines to indicate the proper width, I will draw a rectangle by choosing the Rectangle Corner to Corner command from the sidebar of the Curves tab. Activating End Snap, I will draw the rectangle from the lower left-hand corner to the upper right. To clean up the drawing, I will drag a crossing selection across all of the bar curves. I will Control-click to remove the rectangle from the selection, and then I will hit Delete to throw away the construction curves. Now I need to adjust the length of the rectangle that I've drawn for the support bar. I'll turn on the light blue front layer so I can see the original block as a... I need to scale the length of this rectangle to where it extends beyond the bottom of the block. And I'll do this with a Scale 1D command. So picking the Transform tab, I will click on the lower right corner of the Scale command button to pop out the Scale commands toolbar. And from this toolbar, I will select the Scale 1D command. Select the rectangle as the object to scale and hit Enter. Activate the Mid Object Snap, and then pick at the midpoint of the top of the rectangle as our base point, since we want the top of the rectangle to stay where it is. With Scale 1D command, it's important to hold down the Shift key to activate the ortho constraint, since that determines the direction of the scale. For our first reference point, click on the front C-plane, and for the second reference point, pull down until the rectangle extends below the bottom of the block. Then click. With the drawing complete, I can now extrude the bar. So I'm going to go to the Surface Tools tab, but before I do the extrusion, I want to activate a new layer with a contrasting color so it's easier to see. And then I will go over and select the Extrude Straight command off of the toolbar, select Object to extrude, my rectangle, hit Enter when done. I need to make sure that both sides is yes and solid is yes. Once those are set appropriately, I'm going to pull the extrusion to where it falls inside of the block, but it extends beyond the open channel, so I have a good clean overlap. And then I'll click to finish the command. And that finishes the basic extruded blank for the support bar. Before I continue, I'm going to reestablish top C-plane by hitting T-enter, and I'm going to turn off the light blue block layer so it's easier for me to see what I'm doing. This support block needs to be mirrored to the other side, so I'll go to the Transform tab, select the Mirror Transform command, and then select Object to Mirror, my original bar, and press Enter when done. I'm going to enter 0 to set the start of my mirror plane, and then I'm going to hold down the Shift key to constrain ortho and pull straight back along the y-axis to mirror the bar from left to right, and then click to enter. Now turning back on the light blue front layer, I can see how these bars interact and relate to the original blue block. The next stage for this project is to create a seat for the stones. In preparation for that, I'm going to activate a new layer to work with. I'm going to turn off the blue block, and I'm going to turn off the bars. The geometry I will need to create the seats is a cross section across the middle of one of the stones running from front to back. The tools I will use to get this cross section are a cutting plane and an object intersection curve. For my cutting plane, I'll need to make sure I have my mid-snap active. I'll find the command on the Surface Tools tab off the toolbar on the left. I'm going to select Cutting Plane. The object for my cutting plane will be the stone to the right of center, so select and hit Enter when done. I will pick the start of my cut plane by clicking at the midpoint along the front edge of the stone. To find the end of my cut plane, I need to hold down the Shift key to engage ortho, and then pull either direction along the y-axis, and click. The Object Intersection command is found on the Curve Tools tab by cascading the Curved from Object toolbar. Click on the Object Intersection command button. Take a second to activate the Curves 1 drawing layer, and then select the stone and the cutting plane to intersect, and hit Enter when done. You will see that Rhino has created a clean intersection curve where these two objects meet. At the end of the Object Intersection command, the intersection curve remains selected. Go ahead and click on the Explode command and Control-click on the three segments that form the crown and table portion of the intersection. Then hit Join to join together the two pavilion curves. Use the window selection to select the three top segments that we will not be using, and hit Delete. And then I'll turn off the Curves 3 layer that holds the cutting plane. I need to extrude the stone seats the full length of the channel setting block. The extrusion will run along the x-axis, which means I need to activate the right C-plane by hitting R-Enter. This is because extrusions follow a direction perpendicular to the active C-plane. In the Layers panel, I'll give myself a fresh layer to work with and turn back on the layer holding the main channel block. To extrude the curve, I'll select the Extrude Straight command from the Surface Tools tab, select my pavilion curves for the extrusion, hitting Enter when done, and then pull the extrusion both sides beyond the full length of the block, then click to end the command. I need to establish a cutoff depth for the pavilion setting. In preparation, I'll revisit the Layers panel and turn off the light blue layer to simplify my scene. I want to cut off the stone seat at a level about 1/3 of the way down the pavilion of the stones. I'm going to pop back over to top C-plane for a bit and take a closer look at these pavilion depths. I'm going to use a cutting plane to take this measurement, so returning to front C-plane, I'll run a cut plane command from the Surface Tools tab. My object for the cut plane will be this tray we've just extruded. It's the only object I'll be cutting, so I'll hit Enter when done. I'll activate a fresh layer on the Layers panel and then pick my start of C-plane point on the front C-plane. End of cut plane doesn't really matter as long as it is horizontal, so I'll hold down the Shift key and then hit the Escape key to exit the command. And now I have my cut plane. Now I need to move it into position. In preparation for the Move command, I'll turn off the Surfacing 3 layer to simplify my scene. Type in Enter and select the cutting plane to move. Point to move from, click on the front C-plane, holding down the Shift key to constrain ortho, pull the cutting plane straight up until it's about 1/3 of the way down the pavilions, and click to finish the command. Before I can cut my seat, I need to finish assembling it. So I will turn back on the Surfacing 3 layer and turn off the 3D Curves 3 layer. So the seat extrusion and the stones are the only geometry left in my scene. I need to extract an outside pavilion surface from the two stones at either end of the layout. To make this easier to see, I'm going to turn the seed extrusion back off. Start the extract surface command by right-clicking on the explode button and make sure that the copy option is set to yes. I'm going to select the outside pavilion surface of the leftmost stone to extract. I will then mirror it across the central axis from left to right. In preparation for trimming the seat, I will turn off the stones and turn back on the seat extrusion. I'm going to pre-select these two end caps as trim tools and then execute a trim command. And then click on the two outside ends of the seat extrusion to cut them away. To finish assembling the seat tray, I'm going to execute a join command and select the seat extrusion and the two end caps and hit enter. Now it's time to cut the seat to the proper depth. So I will turn back on the cutting plane and then pre-select the cutting plane in preparation for a trim command. Hit the trim button to begin the command and then click on the bottom of the seat to cut it away. Hit enter to finish the command. I'm going to use this tray as part of two different cutting tools, so I need to make a copy of it in the scene. Starting the copy command off the transform tab, I'm going to select my tray as my object to copy and hit enter. I'm going to activate grid snap so I can copy it off to one side and then bring it back when I need it. Point to copy from, a grid intersection on the C-plane. Point to copy to, another grid intersection on the C-plane. The first cutter I'm going to create will be for the channel set block. I'll begin by turning off the cutting plane. I'm going to extrude the top border of the tray so it breaks through the channel setting block. So going to the Surface tab, I will click on the Extrude Straight command. I'll select the top border from our original drawing and hit enter. I'll turn off Grid Snap and set both sides to no. I'll turn back on the setting block for reference and then pull the extrusion until it clears the top of the block and click to set my distance and end the command. Now I need to extrude the bottom border of the tray until it passes through the bottom of the block. I will turn off the blocks layer for an unobstructed view. I want a single poly curve for this extrusion, and the best command for that would be duplicate border. So after cascading the curve from objects toolbar from the curve tools tab, I'll click on the duplicate border command. I'll select the tray for the duplicate border command and hit enter. The command has created two polycurve borders for the top and bottom of the tray. I only need the bottom border, so I'm going to control click to remove it from the selection and hit delete to throw away the top border. I'll then pre-select the bottom border for an extrusion and select Extrude Straight from the Surface Tools tab. I'm going to turn back on the main setting block as a visual reference and then pull the extrusion through the bottom and click. Turn the setting block back off and then join three parts of the cutter together. Join command and select the tray, the top, and the bottom and hit enter. The final step for this cutter is to make it a solid. So I will pre-select my solid, go to the solid menu and select cap planar holes, which will automatically cap the object, making it a closed solid poly surface. Now that the main cutter block is complete, I want to reposition the tray and the cutter so that the tray ends up in the center of the C-plane. Having them pre-selected, I'm going to hit M-Enter and begin a move command. I need to set grid snap. My point to move from will be a grid intersection. My point to move to will be another grid intersection. I'm going to extrude the top border of this tray the same way I did for the previous cutter. I'm going to pre-select the top border, polycurve. I'm going to go to the Surface tab and select Extrude Straight. I need to turn off Grid Snap to allow for smooth adjustment. For this extrusion, I can just snap to one of the top corners of the previous cutter to establish the height. Since this cutter is for the support bars, there is no need to extrude the bottom downwards. Instead, I'll select the join command, pick the tray, pick the extrusion, and hit enter. And this cutter for the bars is done. The final stages for this model is to assemble it using Boolean commands. First, I'm going to turn on the 3D Curves 1 layer where the support bars are stored. Before I do any Boolean functions with these parts, I'm going to want to put them in storage. So I'm going to select them, Control C to copy, Control V to paste, Control G to group, and Control D to change layer to storage objects. Turning the storage layer off, it's now time to cut the support bars. So going to the solid menu, I'm going to pick Boolean difference, objects to subtract from, select the support bars, hit enter, object cut with, select the cutter and hit enter. The support bar parts are now complete, so I can go ahead and turn off their layer. Using the move command and grid snap, I'll reposition the cutter for the main block to the center of the front C-plane. Then I will turn on the layer containing the main block. Once again, in preparation for the destructive Booleaning process, I'm going to put these parts into storage, so I will select them. And this time I will go through the storage process using the menus instead of the keyboard shortcuts. So, edit menu copy, edit menu paste, edit menu groups, group, edit menu layers, change object layer. And now I can continue with the Boolean command. Solid menu, Boolean difference. Object to subtract from, select the main block and hit enter. Object to subtract with, select the cutter and hit enter. And now the main block part is complete. Next, we need to turn back on the support bars and store our parts prior to the next Boolean. So select the parts, Control C to copy, Control V to paste, Control G to group, and Control D to change layer. These parts are now ready for assembly. So going to the solid menu, I'm going to select Boolean Union. Selecting the objects to union, I'm going to select the main block and both bars and hit enter. This channel setting is now very near complete. All I need to do now is to clean off the top and bottom of the part. The best way to do this is with cutting planes. So I'm going to pre-select my object, and then I'm going to select the cutting plane command off the Surface Tools tab. For the start of my cut plane, I'm going to snap to the midpoint at the front edge of the setting. I'm going to turn off grid snap, and I'm going to hold the shift key down to constrain ortho and click. Now I need to turn my stones layer back on so I can use them as a visual reference. I'm going to use the move command with the shift key to move the cutting plane straight down to where just a small amount of the crown has been left exposed, as well as the table. In preparation for the Boolean command, I'll go ahead and put the parts into storage, copy, paste, group, and change layer. And since this Boolean difference is being done with a single surface, I need to analyze the direction to make sure it's pointing towards the main block, which it is. So, going to the solids menu, I'm going to choose Boolean difference. Object to subtract from is the block. Object to cut with is the cutting plane, and enter. The top of our channel setting is now clean. I want to clip the bottom of this setting exactly 2 millimeters below the girdles of the stones. So, to establish my cutting plane, I'm going to pre-select my block. I'm going to select the cutting plane command off the Surface Tool tab, and I'm going to snap to the internal girdle level of my setting. I'm going to pull straight out with the shift key and click. This is the starting level of my cutting plane. Leaving the cutting plane pre-selected for a move command, I'm going to hit M-Enter to move. My point to move from, I will click on the front C-plane. My point to move to, I'm going to keyboard enter 2 millimeters and hit enter. Then I will pull straight down with the Shift key and click to finish the command. For this Boolean difference, I'm going to need the direction of the surface to point upwards towards the block. So analyze direction, check it. I need to flip it, so flip, enter. Since the construction history of this part is already well represented in the storage layer, I'm not going to bother putting these into storage. I'm going to move straight ahead to the Boolean. So I want to go to the solid menu, select Boolean difference. Object to subtract from will be the setting, and object to cut with will be the cutting plane. Enter when done. So this is the finished setting. That is a professionally usable channel set strip of 2.5 millimeter calibre stones. The next thing I need to do is to clean up my drawing. So turn off the layer for the setting, turn on the layers for my curves, and turn off the layer for the stones. I'm going to select all of my curve objects, group them, and put them on the storage curves layer. Turn off the storage curves layer, turn on the stones, turn on the setting, and I have my finished scene. That is the completed project. Thanks for watching.